Now, before we jump in to actually solving some problems, we're going to do the experiment ourselves. We're going to calculate, as a class, the circumference of the Earth. And we're going to do this by having every single student, and myself, take some data. And then we're going to aggregate that data in the next unit and come to some consensus about what the circumference of the Earth is. There will be errors, and we'll talk about that. This will be a big data set, so we'll have to learn some new skills about how to handle that, but we'll figure that all out in the next unit. For now, we just need to collect the data. So, in order to do this, what you're going to need is a string or a stick. So for example, in the video you saw earlier, I used a string with a weight attached to it because the string needed to be completely straight. You could also use the edge of a building, as long as you know it's vertical and you can measure its height, or anything else that's straight and vertical. You're going to need a measuring device, maybe a meter stick or a tape measure or something like that. Again, the units aren't going to matter because they cancel out when we compute ratios. Next, you're going to need a sunny day, and I understand this could be tricky, especially if you live in a region where it's not so sunny out. Once you have a sunny day, you're going to need to do this experiment as close to solar noon on a flat surface as you possibly can. Now, what's solar noon? Solar noon is when the sun is highest in the sky, and it's not necessarily. In fact, it generally doesn't occur at 12 o'clock. So there's a link below this video where you can figure out what solar noon is in your location. And I hope this isn't too much of an inconvenience for you, but I think this experiment can be done quite quickly, and I think it'll be really interesting to see the data that the class collects, so I hope you participate in this. Of course, you don't have to participate, but it'd be great if you did. Now, once you have everything you need, it's solar noon in your location, you have a sunny day and a flat surface, you have your measuring device and your stick or string. The procedure is basically what you saw in the previous video. Make sure the string/stick is vertical, measure the length of whatever object you're using. So in the case of the experiment I did, that was the string with the mass on it. Next, you want to measure the length of the shadow, and be sure to record both of these. And then you're going to enter your data here. Now, entering data, well, what data do you need to enter? We're going to be doing this experiment a little different than Eratosthenes because I don't want you to have to use a camel to measure distances between nearby cities. So instead what we're going to do is you're going to enter your object length and just enter a number. You don't need to enter any units because, like we said, they don't matter. Shadow length, enter that. Enter your true latitude. So this is the actual latitude of where you do the experiment. And you can find this in a link below. Next, you're going to have to enter the month and the day. Now, why do we need to do that? Think about that for a second. Well, ideally, you're doing this experiment on the summer solstice, which occurs around June 21st or 22nd. That's the longest day of the year in the northern hemisphere. Unfortunately, by the time this class comes out, it's going to be too late to actually get the summer solstice. But it's still right in the middle of summer for the northern hemisphere, and it's pretty close to the solstice, so we'll just have to introduce a small correction to the data, and that's something we'll talk about in the next unit. But to introduce that correction, we are going to need to know both the month in which you collect the data, so that would be June or July, and you can enter June as the number 6, and July as the number 7, so the month will either be 6 or 7. And then you can enter the day. So if you do this on July 1st, you would enter 7 in the month field and 1 in the day field. Go ahead, get your data. I am very excited to see what we come up with as a class.